All right, let's get started with part 2. Oops, that's supposed to be DSMA 9. All right, so this is kind of a silly way of looking at distributive property, but this is Angry Birds. Angry Birds really is math. You're doing parabolas and quadratic, thinking about how you're going to hit whatever those characters are you hit. I don't play Angry Birds. So what's going to happen is on the example, the Angry Bird gets distributed among the two, I think those are pigs inside the parentheses. What we're going to do, that's supposed to be a plus sign, is if we have a number out front of the parentheses, this is really multiplication. And so we're going to take 5 times m, put our plus sign back in. We're also going to take 5 times 12. And then, of course, we're going to clean that up. And so that's going to leave us with 5m plus 60. So this is called distributive property. It's very important. And we're going to have to do that all the time before we can start manipulating these equations if we see parentheses and a number in front. Okay, so this problem only says to solve. We see an equal sign, we see variables, we see parentheses. When we see parentheses, we've got to clean this up. We did a little bit with order of operations, and this is the same idea. We want to get rid of the parentheses. So what we're going to do is take this 4 out front, and we're going to multiply it times each of the 4s on the inside. Lots of 4s going on in this problem. So for the first one, we're going to take 4 times 4x, so that gives us 16x, and then 4 times negative 4 is negative 16, and that's equal to 17x. Now that we've taken care of the parentheses, which you can drop the parentheses once you multiply, now we need to make sure that we can't clean up at all, but we can't. On the left-hand side, we have a variable and a number. On the right-hand side, we have a variable. Okay, so now we have to make a decision. I usually like my variables on the left because I have a little OCD, but because the x on the right-hand side here has a larger number, I'm going to go ahead and move that 16x over to the other side. Okay, so if I do that, this is a positive 16x, so I'm going to subtract 16x, but if I subtract on that side, I have to also subtract on this side. So this is different than division because the x comes along when we subtract. So on the left-hand side, this is now 0. If I have 16 cookies and I take 16 cookies away, I don't have any left, right? So I only have the negative 16 on this side, on the left-hand side. On the right-hand side, I had 17 cookies, but I took 16 away, so I only have the 1 cookie left. And again, we don't usually put the 1 in front. And so I'm actually done. This is my solution. Now with equations, it doesn't matter which way you write it. This says negative 16 is equal to x. That is the same thing as x equal to negative 16 because it's an equation. Okay, so let's look again. It says solve. They were nice enough to say first multiplied to remove the parentheses, but we know that even if we don't see those words, we know that we have to get rid of that parentheses. So the first thing we're going to do is multiply. This happens to be 4 again, but we're going to take 4 times 9y. We're also going to take 4 times negative 5. On this side, we're not going to do anything. We only multiply inside the parentheses. So 4 times 9 is 36, but don't forget the y. 4 times negative 5 is negative 20. Okay, so we took care of distributive property, but now we need to see if we can clean anything up. Doesn't look like it. On the left-hand side, we just have a variable. On the right-hand side, we have a variable and a number, so there's nothing we could do there. But we can move our variables over. So I'm going to move the 36y over to here. Right? We usually go to where the larger numerical coefficient in front of y is. So by doing that, I had 36y minus 36y, so that's now 0. but I have the negative 20 on the right. On the left-hand side, sorry, I was looking because this is going to be a fraction. On the left-hand side, oh no, it's not. We're good. We have 37y minus 36y, so that just gives me 1y. Oop, I spoke before I finished the problem. And so y is equal to negative 20. All right, so this doesn't look pretty because there's decimals and all kinds of things going on, but we know the steps, so we can work our way through this. Let's look on the left-hand side first. It doesn't look like we can do anything. We have a 6x, so we have a variable, and then we have a constant, 8.4, so we cannot combine those. Now on the right-hand side, there's nothing we can do inside the parentheses because we have a variable and a number. However, we do need to distribute that to multiply 2 times 4x and 2 times negative 3.8 so that we can get rid of our parentheses. Okay, so I went ahead and distributed that 2. 2 times 4 is 8, but I have to bring the x along. 2 times negative 3.8 is negative 7.6. So now I have to decide. I could do it either way. I can bring my x's to the left, my constants to the right, which I'm going to probably do because I like x to be on the left, but you can do it either way. So I'm going to go ahead and let's move that 8.4 first. So I'm going to subtract negative 8.4 on both sides. That leaves me with 6x equal 8x minus, looks like 16. Okay, so all I did was move the 8.4. I subtracted 8.4 on both sides. That gave me 0 on the left and just the 6x. On the right, that gave me a negative 16. Now I'm going to go ahead and move my, negative 8x. I should have done it with red. So that leaves me with negative 2x equal negative 16. Because on the right, 8x minus 8x gives me 0. On the left, I'm left with a negative 2. Let me just make a little box here. Didn't leave myself enough space. Okay, so I'm going to divide. Remember that negative 2 is times x. So I'm going to do the opposite. I'm going to divide by negative 2 on both sides. That leaves me an x on this side. And I get an 8 over here. And that's my solution. X is equal to 8. All right, so this one also says solve the equation. We look on the left-hand side, nothing to clean up. Right-hand side, we do need to move that 7 into the parentheses by multiplication. So we have 7x minus 2 equals 7x plus 21. Now, depending on which one you move first, I know a lot of you were taught to move the constants, the numbers first. So let's go ahead and do that. So let's go ahead and add 2 to both sides. Okay, now we're going to move the x's over to the left, but look what happens. This is crazy. On both sides, we get 7x minus 7x, which is 0. This is a problem because we've lost our variable. We cannot solve if we don't have a variable. Plus, we have that 0 is equal to 23. That does not make any sense. That is false. Okay. So as soon as we lose our variable, we have 2 choices. We either have a solution, an infinite solution, or we also call that a solution of all real numbers because every single number works, or we have no solution. For this one, we have no solution. What happens is when you are solving an equation, so up till now, we've had a line on both sides is what happens. And so for those other problems, when we have these two lines, we get a solution in the middle, right? And so where these two intersect, which I can't seem to get anything to write in there, we have x equal to something. But with these two lines, what happened is that these are actually parallel lines. Okay, they don't intersect. So this 7x minus 2 and 7x plus 21 are parallel lines. They don't intersect, and therefore we have no solution. We would have to go back to the drawing board if we were trying to figure out, if we were working in a factory and we were trying to figure out a linear programming problem where we were trying to get workers to be efficient, that would be a problem. Okay, so as soon as you see that you lose the variables and you have a false statement, because this is not true, 0 is not equal to 23, then you know that you have no solution. All right, let's look at all real numbers. So I'll give you a minute to work on this problem. I'll go ahead and work also. Whoops. Okay, so once we move things around, first we distributed the 2. I subtracted 18 from both sides, but that left me with a 0 for the numbers. So I had 10x equals 10x. I subtracted 10x from both sides, and I lost my variable. Okay, so that tells me I either have a solution of all real numbers or I have no solution. So what happened in this problem is I had a line, 10x plus 18. Okay, that was my line. Not a very good line. And then on the other side, I also have 10x plus 18. So this is the same line on top of the other line. So what happens is every single x value in this line is a solution. That's why we say all real numbers. We also sometimes say infinite solutions. Okay, because every single point on that line is a solution. No matter what I put in for x, I could put 0 in for x, I would get 18 equal 18. I can put 10 in for x, I would get 118 equals 118. I could put negative 4,553. I don't know what that answer is, but it would still be the same on both sides. It would be a solution. So again, this is a problem too if you're working on in a factory as a manager and trying to get everything to line up. All right, last problem, we have to translate. So translate the following sentence into an equation, then solve the equation. So we have the sum of 5, 8, and a number amounts to 19. All right, so sum means addition. We're going to, and then a number is going to be the variable. So sum is addition. That means I'm going to have 5 plus 8 plus x. Okay, if it said difference, we would subtract. It might say minus. If it says times, we're going to multiply. It also might say the product for multiplying. For dividing, it's going to either say divide or it could say a quotient. Okay, amounts to is equal, and then we have 19. So for this first box, they literally want you to type all that in. They don't want you to simplify. They don't want you to solve. They just want you to put that into the answer box. But then they want you to solve. So let's see, 5 plus 8 gives me 13 plus x equals 19. I can go ahead and subtract 13 from both sides. And that gives me that x equals 6. And that's going to be the second box.